Swayam Prabha. Digital India. Educated India.
The next basic element we'll be looking at is a resistor. What is a resistor? You are all almost certainly familiar with what a resistor is. It resists the flow of current. Okay, it's given by this symbol, and if you consider the voltage across it and I a current following the passive sign convention, what a resistor does is to establish a relationship between the voltage across the resistor and the current through the resistor through a proportionality constant, which is a property of the resistor. Okay. So, whenever we specify a resistor, we also give its value R. Okay. What does this mean? The voltage is proportional to the current, and this proportionality relationship is known as Ohm's law. Okay. And the proportionality constant is called the resistance. The resistance is the voltage across the resistor divided by the current through the resistor, and it has units of volts per amperes, which is basically given by this symbol omega, which is called ohm. Okay. So, a 1 ohm resistor has 1 volt across it when 1 ampere is passing through it. Okay. And the proportionality constant is the resistance. Okay. Now, this relationship V equals IR can be inverted to get I equals V by R, or I equals G times V. Okay. And this G, which is 1 by R, is known as the conductance of the resistor. Okay. And this conductance is measured in Siemens. Okay. So, if you have a 1 ohm resistor, it is the same as saying it has a conductance of 1 Siemens. If you have a 2 ohm resistor, it is the same as saying the conductance is half a Siemens. Okay. Now, I think again all of you know how a resistor is made. It is basically some resistive material. The prototype that you see in textbooks consists of a rectangular bar of resistive material with one terminal here and another terminal there. As I showed earlier, the symbol for a resistor is this with 2 terminals. Let me call this A and B. Okay, A and B. And in a resistor like that, a current is assumed to flow uniformly across the cross section in this way when a voltage is applied here. Okay, I will show the symbol on the right side. Okay, and let us say the cross sectional area of this face is something, and the length along which the current flows is some length, and you know that the resistance is given by the resistivity times the length divided by cross-sectional area. Okay. Now, as I mentioned earlier while talking about circuits in general, we will not worry about these details. Okay. For us, the value of resistance is what is given. Okay. Once the value is given, all we need to use is the terminal relationship V equals I times R. We don't have to worry about how this resistance is calculated. Now, this formula is simple enough for a rectangular bar like this, but if I had something uneven, okay, some uneven shape like this with curves and so on, and I have a terminal here and a terminal there, it becomes quite complicated to carry out these calculations. Okay, but for analyzing circuits, we don't have to worry about it. Okay, as long as it's a resistor, the voltage across it will be proportional to the current through it, and the proportionality constant is given by R. Now, whoever is designing the resistor will carry out the calculations for an odd shape like this, if you do make an odd shaped resistor, and tell you that between these we have a certain resistance R, and as far as we are concerned, we simply use this in our formula V equals IR to analyze circuits. Okay. So, this is what I also meant by we don't worry about spatial extents of things, because we are concerned only with terminal characteristics. We will use only the terminal characteristics. Okay. So, life is a lot simpler for us. If you do want to calculate how much resistance a bar contributes between some terminals, you do need to use electromagnetics. But once that resistance is determined, you can make circuits with it and analyze circuits with it by using the terminal characteristics, which is given by Ohm's law. Okay. Now, as before, we also sometimes depict the characteristics graphically. We have I and V, and V is given by IR, and if you take a physical resistor, the resistance will be positive. Okay. That means that if you take a bar of material and connect two terminals to it, and you measure the proportionality constant between V and I, you will find a positive constant. Okay. What will that curve look like? It will be a straight line passing through the origin, and the slope of this, remember we are plotting I on the y axis and V on the x axis. The proportionality constant is the conductance or the reciprocal of resistance. Okay. If you had plotted V versus I, the slope would be the resistance. Okay. So, many times you can use this graphical characteristics to either visualize intuitively some solutions or even sometimes carry out the calculations. Okay.